Hello everyone, this is a Samsung Plasma TV PN58B550T2F. Alright, the customer said the TV was working fine, and one day he heard a big pop, then the TV goes off. Plug the TV to the power and we see what it's doing right now. So I hear the relay clicks, then click back. We hear the sound, then goes off, and the relay start clicking. The timing control board is, I see the light flashing, and stop flashing now. Let's try again. Okay, we need to wait then. Well, I can see that light flash, then there's light. We hear the relay, we hear the Samsung logo sound. Okay, let's try again to see if we can get it. If we get any picture. Yeah, there is no picture. So the TV turns on and it goes off. In the Plasma's TVs, the first thing we check in this case is the VA and VS. And you can find a sticker on the back of the TV showing the VA it should be 55. The VS is a 201. So we get the multimeter. We put the black probe in the ground. We have a test point right here. That's a VS. And we have the test point for VA is here. Plus we can test them here in this cable. Yeah, we have VA, we have VS, and we have 15 volt. So let's see, I'm gonna plug it and we check. So we put this one in the VA or VS. So it's go 1 volt, 14 volt, then goes off. It doesn't go more than 16 volt. So what about this one here? No voltage at all. Could be something blocking this voltage to be on, or could be the power board is not giving that voltage. So let's disconnect this cord. This is the X board, that's the Y board over there. So this cable here is going to the X, this cable going to the Y. We check in the VA or VS. Yeah, it doesn't go. We check here. It doesn't go. So usually when if you have a problem in the Y or X board and you disconnect these two cables, the voltage is going to show for a fraction of the seconds and goes off. But at the moment the voltage it doesn't show. All right. So check this 15 volt, this pen here. There's everything marked in the board. You can say 15 volt. This is what the Plasma TVs are good. You can see 15, it shows, then it goes off. That's good. On this connector that's going to the main board, we have DC detect right here. It should be exist because the TV goes on. That's good. We have 15 volt in this pen, number 2. can see 15 volt. Then we have ground, and we have 5.3 volt. That's 5 volt over there. VM, that's the voltage for the sound, should be exist because we did hear the sound. Then let's see the V on, VS on, and VS and PS on. So VS on 3.2, yep. So the main board is sending the voltage to the power board to turn on the VS. And of course the PS on, we're gonna find it on. Okay, that's the PS on. The PS on, when the PS on is low, the power board, it will be in the on mode. When the PS on is high, like now you can see it is at 2.6, the power board is off. But if the power board turn on, the PS on goes off. That's normal. For this pen, the PS on, when it's go low, is mean the main board is shorting that voltage to the ground, telling the power board to turn on. All right, the standby. Of course, we are going to have the standby because we hear the sound. Yeah, that's good. All right. In this cable that's coming from the timing board to the power board, we have VS on, PS on, and we have 5.3. So here is 2. The same thing, PS on is go high when the power board is off. 5 volt. Here is 5 volt. So we have all the other voltages except the VS and VA. Yeah, we can check some fuses. Yeah, this fuse is good. We check the fuses and the power supply. This fuse is good. This fuse is good. The input fuses, these two, they should be good because the TV turns on. Yeah, I did find something, and that's what I found. This fuse here, when I test the fuses, this fuse, I find it open. And same, there is another fuse here, is open. So I check it. So let put this one on the ground. So I check it if the fuse, any side of the fuse connected to the ground or shorted to the ground. It's not. I put these little jumpers. This little jumper after. Then I check this fuse here. Is good. This low ohm resistor is good. I check all these MOSFETs. These MOSFETs here. None of them is shorted. Yeah, these MOSFETs, none of them shorted. This is a diode. Yeah, the diode, usually they have the first and the third pin connected together. There is another fuse right here is good. These MOSFETs. So this is a MOSFET. No short. no short. So all these MOSFETs, I test every single MOSFET in this board, no short. Same thing in the other board. Yeah, the little fuse is good. The low ohm resistor is good. One fuse here is still good, but the fuse is open, so no short to the ground from the fuse. I checked all the MOSFETs, they are good. There is no short. So for that I did put a jumper. I solder a small wire to the fuses, plugged the TV still doing the same thing, exactly the same thing. So we don't have no short in the both boards, and we don't have the VS and VA. Then we go check the board. Oh, you see that? See, something burned the other side of the board. The board was like this, and yep, it's over there. You see that? That one's are burning. All right, that's the burn spot here, and yeah, that's the connector for the VA and VS, and you can see these diodes. So this is a diodes. You can see a DS. So we have a short right here. So any short in this MOSFET. No, it's not short. No, that's not MOSFET. This is a coil. Yeah, that's the transformer coil. We have a diode right here. No, not short. So let's clear up the pads on this diode and we test them. Just we want to be sure there is no short. Yeah, look like this diode here, which has a little crack around the pads or around the pins. Yeah, the middle pin is already is already disconnected, so there is no connection. You can see the copper here is gone. Yeah, so there is no connection between this pin and here. Alright, so now, let's see if there is any connection, this one to the pin. No, from here to this pin, no. So now we can test the diode. So open, and if we flip, yeah, this diode is bad. Yeah, that diode is bad. So this one. This diode is good. So let's see. Yep, there is no connection between the diode and the pin. No, still connection over there. Yep, no connection now. Yep, it's shorted. Yeah, one side of this diode is shorted. No, this diode is not shorted. Two diodes are shorted, this one and this one. And there is a rectify bridge. We are going to test it too. But rectify. So no short in the input or the output of the rectify. And there is a short in the input. How come? Anyway, let's check the diodes. I'm gonna take that rectify bridge as well because I don't like that shortage. So it was testing short right here. That's good. That's good. Alright, so all these diodes is, two diode is in, two diode is out. Okay, let's see. Okay, this diode is good. Short, yeah, one side is shorted. short. So this one, these two diodes are short. Yeah, I find two diodes. This one's here in this donor board, and this one is a FCF10A40. The diodes are facing in. This one here, yeah. So it's mean 10 amp and 400 volt. The other one is a FRF 10A40 and the diode facing out. This one right here. So the same thing is a 10 amp 400 volt. The diode that we have, this one, the diode facing in, is a 10 amp and 300 volt. The one that the diode facing out is a 10 amp and 300 volt. So let's see. Yeah, this one, the diodes facing in. You can see 10UC30 is mean 10 amp 300 volt. This one, the diode facing out, is a 10 amp and 300 volt. So the diodes that we are using is more strong than the one the manufacturer uses. When you see that 400, is not mean this diode is giving 400. But it means this diode is handle the maximum 400 volt. This one only handle 300 volt. The same as the capacitor. When you see the voltage in the capacitor, if it is a 10 volt and you put a capacitor with the 16 volt, it will work great, because that capacitor can handle the voltage up to 16 volt. So it's good to go more voltage and it's bad to go lower. Alright, yeah, I dropped the screw over there somewhere. We don't need to leave it. Let's make us short. Alright, this one, it works, looks good. The diode facing out. This means it will be this one's here. So this one. Yeah, one diode is good. I checked all that. Yep, you can see the diode is facing. Okay, this one is good. Alright, this one is good. Oh, this is the bad one. So basically we have just one bed. This one is good. Oh, this one is bad. So why this does it good? Yeah, this completely, this one is bad. So the diode in this one is, it has a partial short. So the pins are a little bit short. Right, yeah. The solder goes all the way to the other side. So let's test if there is any short. No short. No short. Alright, let's see. Look like that's not a short, that's just the coil. Alright, let's test it. So we still want to understand why the diodes is burned. This is why I'm not going to connect these ones in case If there is any wrong voltage, we won't send it to the good board. So I'm going to put this one in VS. I'm going to plug quick, and if I see any voltage here, any wrong voltage, I'm going to unplug it. I did see 300 volt. That's not right. And here it should be 55 volt, the VA, but look, it's already over 80 volt in the capacitor and the RT charging. So there is something wrong in the current circuit. So this is the switching IC. It's got the voltage, so the switching IC is sending the signals to these two MOSFET to start current. They cut the voltage for these two transformer here, these two transformer to these 4 diodes, then to the output. But at the moment, from these diodes, we should have some feedback to the IC, for the IC to know how much is the voltage is output. So look like something wrong in the feedback circuit or something wrong in the IC. The voltage is always, it keep getting high. It could be the IC is bad, or could be the feedback. So let's just check it and we'll go from there. Yeah, I will start with the optocoupler. So always start with the easy parts. So if you see this section here, it's all this stuff is come to this optocoupler. The pin number 1 is right here. And that's the pin number 1. There's a glue in it. So this one, the pin number 1, it's right here. Yeah, because the optocoupler, that's the component telling the IC how much voltage it's here. And that's how the IC is gonna like switch in faster or slower, the MOSFET. Okay, yeah, let's try it. And this is explaining why these fuses burn, because it's sending over 300 volt to that fuse. Yeah, let's check with the multimeter. I'm just going to turn on the power quick. If I see the voltage raise over 200, I will turn off the switch. So I turn off the switch, turn on. 17, I hear the sound. It's stuck at 176. That's a good thing. And the VA, 48 volt. So yeah, look like we need some adjustment here. So we can adjust the VA to be 55 volt. No, that's all. It doesn't go more than that. the voltage it's stuck at 170, and this plugs is not plugged. So I find this optocoupler is matching exactly the same part number of the original optocoupler on this board. So this one is a 2561A. So just this one is going the board holes, and the other one is a SMD. So yeah, we can bend the legs so it can match the board. Alright, let's test it again. We are not going to plug the Y and X board till we be sure we have the right voltage, because we don't want to burn them. Alright, I'm going to turn the switch and we'll watch the voltage. Oh, something wrong. No, I wasn't connected good. Let's try again. $175 here. $47 volt. I changed the optocoupler twice, but we still have the same, like 175 volt. Okay, let's go in the diode mode, or in the resistance mode basically. The output voltage is go to some resistors here, and is go to the TL. I think that's a TL. And it's go to the optocoupler. Yeah, I don't see no other TL. Should be, this is the TL 431. That's the shunt regulator. So let's check this resistor right here. Is a 1001, is mean 1 kilo ohm. It's good. Well, let's go to the microscope, is better. So we have 1 kilo ohm right here. That's good. We have 470 ohm, 480. It's okay. We have 1.6, so it's close to it. So we're looking for a big difference, like an open resistor. 200 or 2 kilo ohm here, 2.4 exactly. 273 is a 27 kilo ohm, or 270. Yeah, that's a 27 kilo ohm. We have 10 kilo ohm. This one is 15 kilo ohm. So all these resistors are 15 kilo ohm. Fifteen. and 15. Let's check. Yeah, the resistors is okay. Any shorted capacitor here? 3 kilo ohm. No shorted capacitor. What about the TL? The shunt. No short, of course. Three ohm? That's not right. 1 kilo ohm. Yeah, 3 ohm here. So shorted, I think, to the ground, no? Yeah, that's the ground. See, that's the negative of the capacitor. How is the capacitor? Is it shorted? No, the capacitor is good. So that's the negative side of the capacitor. And look like that's the... Let's go to here. So let's check this one. No, 1 kilo ohm. So basically we have a short in the TL. So let's see the name of it. Is a 443F. Is a 43F. Let's go SMD. We go all. Let's go to here. And we're gonna go 43F. 43F is a shunt regulator. That's the one. So we have the number 3 is the anode, number 1 is the cathode, and number 2 is reef. Now let's find another shunt, another TL. Alright, this is the optocoupler. So here is the optocoupler, and it's gonna be in the other side, it will be the TL. So this is AS431A. So let's go check that one. So this is the AS431, and we have the 3, the anode, the 1, the reef, and the 2 cathode. Sounds like a little bit different. Here we have the 1 is the cathode. Now we need to figure out where is the anode, where is the cathode. So we have this pin is connected to this side of the optocoupler, to this side. Yeah, this pin is connected to the voltage from the output. This pin here is connected to the ground, as you can see that. Yeah, that's the negative side of the capacitor. Okay, 1 ohm. 1 ohm, yeah. So this pin here is connected to the optocoupler. So let's see if we have the same setup for the same, this one right here. So what's the pin? This pin here, it should be connected to the ground. This one here. So let's connect it to any ground. Okay, I put the probe in metal, and I put this one. We have 3 ohm. That's good. So this anode is connected to the ground. This pin here, it should connect to the optocoupler. I think it's connected to here. Yeah. So we have the same setup. That's good. Now let's take it. Alright, let's check the other one if there is the shirt in it. So it was a shirt right here. Yeah, it's low ohm. Okay, this one there is any shirt. Mega ohm. That's good. Overload, that's good. So let's test it. Power plug is good, and I'm going to turn on the switch. So just we keep our eye on the multimeter quick. So if we see the voltage rise high, we need to disconnect. Yeah, I'm going to put it in VS this point, and we are going to turn on the switch. Okay, 210, 209, very good. 56. Bam. Fixed. All right, let's turn off the switch. So now we can do some adjusting in these ones before we connect the Y and X board. So let's turn on the switch. Here is going down. We need to go to the 5. Here is 5. The other switch should be 55. Yeah, it's a 55. Here, 55. $55, 204. Okay, we need to get it down a little bit. We need 201. As it show here, 201. The other one is 55. Good. Let's check the voltage before we plug the cables. So it's about 400 millivolts. Yeah, the capacitor discharged. So let's connect this one safely now. I plug the board, or I plug the TV. Okay, let's see what we have now. 201 exactly. So next test, do we have the picture? We have the picture. You can see over there. Picture looks good. So the TV is fixed.
Good, Alaska. The cruise ship will be cruising. They do have cruises for Alaska. I don't think that would not be no fun. It would be a good price because we don't have to.
They changed the fuse. So these fuses is just for testing. We put the wires in them. Yeah, just for testing. So now everything is good. We can put the TV together. and check the picture, then we go from there. All right, we put the TV together. The picture looks good. And let's put just something on the to see the picture and to sound. Yeah, picture works, sound works. Everything looks good. Yeah, so even if we put a white screen, there is no flickering. So that's all for this video. Thank you for watching, and we'll see you again.